Welcome to an intro to partial fractions. So the general idea here is if we want to integrate a rational function, we have a few particular rational functions we already know how to integrate. So for example, if we have the integral of 1 over ax plus b dx, we could do u sub if you want, you don't need to. But if we set u equal to ax plus b, then we have du is a dx, which means that dx is 1 over a du. And so we wind up getting that this integral is the integral of 1 over u times 1 over a du, otherwise known as 1 over a times the natural log of the absolute value of u plus c, or 1 over a times the natural log of the absolute value of ax plus b plus c. You are welcome to jump straight from that first line to the last line. You don't need to work through the u substitution. Anytime we have a linear inside function, you just get that 1 over a out front. We have also seen if we have an integral of 1 over x squared plus 1 dx. This was tan inverse of x plus c. And then, of course, we have the variations of that. If we had the integral of 1 over x squared plus a squared dx, that was 1 over a times tan inverse of x over a plus c. If we have other things, we can do u substitution for them. And then let me update my screen quickly. If we had a variation of this last one, if we had the integral of 1 over x minus b squared plus a squared dx, that just winds up being 1 over a times tan inverse of x minus b over a plus c. Again, we can get that by using u sub, with u equaling x minus b and du therefore being dx. We also have, if we have an integral of 2x over x squared plus a squared dx. Let me actually move this onto the next row. So if we have the integral of 2x over x squared plus a squared dx, or simplifying that, if we just have the integral of x over x squared plus a squared dx, we can go ahead and do u sub if we set u equal to x squared plus a squared. Then we have du is 2x dx. And therefore x dx is 1/2 du. So this integral winds up being the integral of 1 over u times 1/2 du. We get 1/2 the natural log of the absolute value of x squared plus a squared plus c, or as well, sorry, we would have had a u first, 1/2 the natural log of the absolute value of u, which becomes 1/2 natural log of the absolute value of x squared plus a squared plus c. And we have, again, other variations of this, but essentially, if we have any linear factor over a quadratic, prime quadratic, or something, a constant over a linear factor, we can integrate it. So if we have integral of a constant over ax plus b dx, we can integrate it. And similarly, if we have an integral of a linear cx plus d over an x minus b squared plus a squared dx, we can integrate it. And so what we will want to do is, it turns out that we can break any rational function up into copies of these more or less. So it turns out we can break a rational function into a sum of rational functions with these denominators or possibly powers of these denominators. And so our job will be to break these rational functions up. Our job will be to break up the rational functions into what we call partial fractions. So in the next video, we will look at some more basic cases, and then we will get into the more complicated cases of breaking up our rational functions into smaller fractions that we know how to integrate.